Hi guys, this is Hw9. I'm doing homework 9, question number 1. So we're given that z of t is n1 of t times cosine wct plus theta minus n2 of t times sine of wct plus theta. Theta is uniformly distributed from 0 to 2 pi. N1t and N2 of t are wise and stationary process, and N1t, N2t, and theta are independent. So first we are asked to find the exact value of z of t. Before we do that, we know since N1t and N2t are WSS, then the exact value of N1t is a constant n1, and the exact value of n2t is another constant number n2. So for the first part, we just do the exact value of the whole thing, and since they are all independent, we can separate them to the 4 parts like this, and the cosine, the exact value of the cosine function becomes 0, and also for this one is 0. So the whole thing, which is the exact value of z of t, is 0. The second part, it looks complicated, but we just have to write it out and then be careful with the calculations. So the first part, we are looking to find Rz of t1, t2, and we are asked to find if z of t is wise and stationary. So Rz of t1, t2 is just the expected value of zt1 times zt2. And zt1 is n1t1 cosine wct1 plus theta minus n2t1 sine wct1 plus theta. Here we just substitute t1 to all the t in z of t. And for z of t2, we do the same thing. We substitute t2 for all the t's in z of t. Now we just multiply them, and this becomes the exact value of zt1 times zt2. And to simplify this, I wrote, to make it look clear, I wrote this for A, this second part for B, the third part as C, and the fourth part for D. So this becomes the exact value of AC, because this is the exact value of A minus B times C minus D. So it becomes A times C minus A times D minus B times C plus B times D. So A times C here is n1t1 times n1t2 times the cosine times another cosine with t2 inside. So and also because this is t1, n1 of t1 times n1 of t2, this becomes r n1 tau, and tau is just t1 minus t2. So I did the same procedures for the other AD, BC, and BD, and after we simplify them, we can see that the exact value for AD plus BC equals 0. So we have it here, AC minus AD plus BC plus BD. So if AD plus BC is 0, we just do AC plus BD. So here it becomes, the whole thing becomes half of r and 1 tau minus r and 2 tau times cosine WC tau. And I just want to mention that the way I did it here, as you see here, it's cosine alpha, cosine beta, cosine alpha, sine beta, sine alpha, cosine beta, sine alpha, sine beta. So using the trigonometrical properties, we know that cosine alpha, cosine beta is like this, and all of these have their own properties. So I just use this here to simplify this. And now we know, and since this is a function all about tau, the only thing that changes in this function is tau. So we know that z of t is Weissen's stationary process. And so this is for part 2. And for part 3, we are looking to find rz of 0, and rz of 0 is just so we just substitute 0 for tau here, and this becomes, and cosine 0 is 1, so this becomes half of r and 1 0 minus r and 2 0.